All right, we are going to learn a new method of solving systems of equations. And when I say systems of equations, I mean two equations and two unknowns. So last week we were solving systems of equations with the substitution method. We have a new method now, and it is called elimination. And it'll be clear in a second why it's called elimination. So let's look at the first example. So you've got your notes. You should just be writing as I go. So notice I've got two equations here, and look at the coefficients on the variable y. One of them, the top equation, the coefficient is -6. The one on the bottom, the coefficient is +6. So they have the same coefficient. One's positive, one's negative. What happens with elimination is this. When I go to perform my elimination, what I'm going to do is I'm going to add the two equations together, like they were two numbers being added together. Only now you're more advanced, you're doing a little bit more complicated things. So be careful. When you add these two equations together, you're going to be adding the x terms together. So you're going to add 5x plus 3x, which is 8x. Then you're going to add -6y plus 6y. What is -6y? I'm going to just go off to the side. What is -6y plus 6y? And hopefully all of you realize that it's just 0. They cancel each other out, right? There's nothing left. That is the beauty of elimination. So this is going to equal now. The 6y's have canceled out. They're no longer there. Y is gone. And we're going to be left with 16. -32 plus 48. I'm going to maybe just do some calculations off to the side so you know what I'm doing. I'm adding my two things on the other side of the equal sign. Next thing I'm going to do, solving for x, I'm going to divide by 8. And I get x is equal to 2. Alright, just like substitution, once you get the solution to one of your variables, you just plug it back in to get the other. So I'm going to take this, plug it back in. I'm going to use the second equation that looks a little bit easier. So 3 times 2 plus 6y has to equal 48. Alright, so 6 plus 6y equals 48. Subtract 6 on both sides. 6y is equal to 42. That means y is 7. Okay? Alright, so write your solution as an ordered pair. So in our case, this would be 2, 7. And if you have time, I would always check your work. Take that solution, plug it back into both equations, and make sure that it works. Alright, so it's a pretty nifty method. It saves you a lot of time sometimes. So let's look at another example. So go to your second example. Alright, now let's analyze this. I've got, again, two equations, two unknowns. My coefficients on x are the ones that have the same coefficient, one positive, one negative. So I'm going to add my two equations together, and when I do that, 2x plus -2x, they cancel out. There's no more x's there. So you could write 0 here if you wanted. We'll just do that for a second, and then I'll erase it here. Alright, now I need to add the y terms. So 3y plus y. That's going to give me 4y. So I have 0 plus 4y is equal to, then I need to add 20 plus 4. Alright, and that's 24. Alright, so over here, when I'm making these calculations, you don't need to ever include this in your work. If you can just do it in your head, that's fine. So 0 plus 4y is just 4y. I'm just going to get rid of that. Alright, so the beauty again is that the x terms now are eliminated. They're no longer there. We can just solve for y. Divide both sides by 4. Y is 6. Alright, to get x, I'm just going to plug this back in. I'm probably going to use the second equation because that looks a little bit easier. So that's going to be -2x plus y, in this case 6, is equal to 4. So I'll subtract 6 on both sides. -2x is equal to -2, x is equal to 1. All right, so our solution at an ordered pair is 1, 6. All right. Okay, the next two examples are a little trickier, and let me show you why. So on my two equations here, my x terms have the same variables, or sorry, the same coefficients, which is a lot like our last one. They both have 2's out front, but notice on our last one was positive and one was negative. So when I added them together here, they canceled out. But this one here, one's positive and the other's positive. So if I were to add these together, two equations, you don't have to write this down, but you would end up getting 4x, and then if you added negative 2y plus y, you would get minus y is equal to 1. And so the problem is you haven't eliminated any variables. So we're going to do something different. We're going to erase that. And what I'm going to do is I'm actually going to subtract the two equations. So you can subtract equations just like you can add them. So what happens when I subtract is I get 2x minus 2x, and that eliminates the x variable. So I'm going to have the x terms cancel out. Now again, I'm subtracting the whole second equation. You can think of it like you're subtracting this whole thing. So I need to subtract 2x minus 2x, but also I need to subtract negative 2y minus y. Okay, so that minus sign distributes to each part of the equation. So what is negative 2y minus y? That would be negative 3y. And then again, another calculation I need to make is negative 1 minus 2, which is on the other side of the equal sign negative 3. So y turns out to be 1. All right, so I'm going to use that, plug that back in. 2x plus 1 for y is equal to 2. I'll subtract 1 on both sides. 2x is equal to 1, so x is equal to 1/2. All right, so my solution is 1/2, 1. All right, so same thing. If you have time, you want to check your work. Let's look at the last one. Okay, so let's analyze our situation here. This is a little different. Looking at your y terms, they both have the same coefficient of 3. Now the problem is, if I add the two together, let's say I want to add them together, I would end up getting 4x, and then negative 3y plus negative 3y is negative 6y. And you could add the other side. But the long story short is that it didn't eliminate any variables. So we don't want to do that. Let's see what happens if we subtract the two equations. So over here I'm calculating, making some calculations over here. I have x minus 3x. That's negative 2x. Now here, negative 3y minus negative 3y. When you subtract a negative, this becomes plus. Now look and see what happens. You've got negative 3y plus 3y, and the y terms actually cancel and they're eliminated. All right, so this is going to work. Subtracting the equations is going to work. All right, now I need to subtract 27 minus 39. Make your little calculation is negative 12. So x is equal to 6. So I'm going to take that, plug that back in. Probably to the first equation looks easier to use. So I'm going to have 6 minus 3y is equal to 27. All right, so really quick, I'll subtract 6 on both sides. Negative 3y is equal to 21, which means y is negative 7. I'm going to write this solution as an ordered pair, and that will be all. All right, so we'll talk more about this on Monday, but there is certain strategies as you approach these, and you have to decide whether you're going to add the two equations or subtract the two equations. All right?